DynHP is a process that optimizes AI models to make them more efficient. This allows AI inference to be performed on resource-constrained devices in the fog or edge layers. The current version of DynHP implements a structured pruning methodology. DynHP incrementally removes sets of parameters of a deep network model during the training process. DynHP was initially designed for pruning on resource-constrained devices. It implements a mechanism that allows for free memory while the training and compression process proceeds. The DynHP pruning process is one way. Once a set of parameters has been pruned, that is set to 0, the decision cannot be reverted. Since this approach makes the stochastic optimization process more challenging than usual, DynHP adopts an automatic dynamic batch sizing to counterbalance the potential adverse effects caused by the pruning process itself. In task 3.5, during the first year of Marvel, the development of DynHP was mainly methodological. We refined the pruning methodology and worked toward extending the types of deep network models to be included. Currently, DynHP successfully prunes both multi-layer perceptron and standard deep convolutional networks like wide ResNets and VGG, applied to image classification problems. The current activity is to apply the methodology to more complex deep neural network topologies used in the Marvel use cases. The DynHP component is part of the AI training workflow in the Marvel architecture. As with any other AI component, it interacts with the data corpus and the AI model repository, which is a storage based on MinIO collecting all the AI models produced in Marvel. Each model in the AI model repository is accompanied by a model descriptor based on the FireWire standard, customized with additional fields to meet our needs. Once identified a model to compress, DynHP downloads from the AI model repository the originally trained and uncompressed parameters with its model descriptor and starts an offline compression process. The compressed model is then uploaded again to the AI model repository with the corresponding descriptor, ready to be used by the other AI components for inference.
In this demo, we show the process of compressing an AI model using the DynHP component and the necessary steps to interact with the AI model repository. Let us now access the demo instance of the component. First, let's identify the bucket corresponding to the use case we are interested in. This is possible by simply listing the available buckets on the AI model repository. In this case, we will refer to the UNS1 use case, where we can see that contains several models together with the corresponding JSON descriptors. Let's focus on the PyTorch model created for this example, identified by the keyword example. Let's now download the model that we want to compress. Now we pass to the compression phase. Note that this phase is equivalent to train the model or to fine-tune it. The compression process takes in input the original uncompressed model, the name of the output that will contain the compressed model, and the dataset to be used in the process. In this case, the Disco dataset. Please be aware that the compression process involves some manual effort, which should go beyond the time limits of this demo. Therefore, for the interest of time, we simply simplify the process. Once the compressed model is ready, we create the corresponding fireware-compliant file descriptor in JSON format. According to the naming convention, both the model and the JSON file must have the same name. Once ready, we upload both files to the AI model repository. Finally, we can check that the compressed model appears in the list of the available models in the corresponding bucket, in this case UNS1. As we can see, 2 additional models appear in the bucket, identified by the keyword compressed. In this way, any other user can download, process and prepare the compressed model for deployment, according to the specific needs of the scenario.